We're now going to take a look at the identity and inverse matrices. So let's take a look at the identity and inverse matrices. The identity matrix we're actually familiar with already because previously when we did Gauss-Jordan elimination, we always wanted 1, 0, 0, 1, and on the opposite side was our solution. The left side is called the identity matrix, which is denoted I sub n. And what's great about the identity matrix, in addition to what it does for us in Gaussian and Gauss-Jordan elimination, is if I take a matrix and I multiply it by the any matrix, really. If I take a square identity matrix and multiply it by a matrix, I should end up back where I started. So here I should get 4 times 1, which is 4, plus 2 times 0, which is 0. So that's 4. And then 4 times 0, which is 0, plus 2 times 1, which is negative 2, which gives me negative 2. And then if I take 3, 0, I get 3 plus 0, which is 3, and 0 plus 1, which is 0. 0 plus 0, excuse me, which is 0. And notice I started out at 4, negative 2, 3, 0, and I ended up at 4, negative 2, 3, 0. That is what the identity matrix does. The inverse matrix, which is what our next video is about, is how to find the inverse matrix. But the inverse matrix says that if I take the inverse times the original equation, so the inverse of a matrix times its original matrix, I should end up back at the identity matrix. So let's test that theory. I've got 0 and 1/3. That would give me 0 plus 1/3 times 3, which is 1. And then 0 plus 0, which is 0. Then I would take negative 1/2 and 2/3 and do the same thing. So that would give me negative 1/2 times 4 is negative 2. And then 2/3 times 3 is positive 2. I add those together, I get 0. And then negative 1/2 times negative 2 is positive 1 plus 0, which is 1. And notice I did end up at the identity matrix. And if you needed to show that step in between there, you certainly could have done that. I just, for the sake of time, went straight to the solution. So this question asks us to determine if two matrices are inverses. So like we did on our last one I told you it was an inverse. This one I'm asking, are they inverses? Which means if I multiply them together, I should get the identity matrix. So let's take a look. If I took A and I multiplied it by B, I should end up at the identity matrix. So let's just verify that that is in fact true. If they are inverses, it will be true. You are going to have to do some addition and multiplication with fractions, so get those calculators handy if you need them. So first one is negative 5, 2. That gives me positive 5/4 plus negative 2/8, which is negative 1/4. And then positive 5/4 plus negative 10/8, which is negative 5/4. And then I change to my second row. And my second row is 1, negative 2. And then I'm going to take negative 1/4 plus positive 2/8, which is positive 1/4. And then 1 times negative 1/4 is negative 1/4. Negative 2 times negative 5/8 is negative 10/8, or negative 5/4. Oops, sorry, positive 5/4. I knew I did something wrong there. And then my solution is, of course, what happens when I combine those. So 5/4 and negative 1/4 is 4/4, or 1. 5/4 and negative 5/4 is 0. Negative 1/4, positive 1/4 is 0. Negative 1/4, positive 5/4 is 4/4, or 1. So I ended up back where at the identity matrix, which is what I wanted. I could also do that in reverse. because I know how much fun you have when you are multiplying fractions and dealing with matrices. So let's just do it for fun and see what happens. So now I'm going to multiply in the opposite order. And God willing, we're going to end up back at the identity matrix yet again. Let's just see how good we are at math right now. So take this guy and turn it into a row, multiply it by a column. That's negative 1/4 times negative 5 is positive 5/4. Negative 1/4 times 1 is negative 1/4. Add those together, I get 4/4, which is 1. Negative 1/4 times 2 is negative 2/4, which is negative 1/2. Negative 1/4 times negative 2 is positive 2/4, which is positive 1/2, which is 0. And then I move on to the next row. Negative 1/8, negative 5/8. Do the same thing. I get positive 5/8 plus negative 5/8, which is 0. And then I get negative 2/8, which is negative 1/4, times positive 10/8, which is positive 5/4. And when I combine those together, I get 4/4, which is 1. So they are, in fact, inverses of one another.